Stage 1 fuel bleed complete. Vehicles in self-align.
LD verify go for launch.
We'll go for launch.
Stage step closed out.
C, verify Falcon 9 is in startup.
Falcon 9 is in startup. The flight computer has control of the vehicle. Stage 2 tanks pressing for flight.
T-minus 30. T-minus 20.
Stage 1 tanks pressing for flight.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff.
You saw the liftoff of the Falcon 9 from Space Launch Complex 40. We're going to follow it from the pad cameras as well as the vehicle cameras. Shortly you heard T plus 30 seconds the vehicle was active on propellant utilization. We're now controlling the rate that liquid oxygen and fuel are consumed out of the tanks. We want them to burn out evenly, not use up one or the other too much.
Vehicle is supersonic.
Stage 1 propulsion is nominal.
You heard the call out, propulsion is nominal. You hear the chewing in the background. We have passed supersonic. It's dark. The sun set several minutes ago at Cape Canaveral. You didn't get to see the shock wave as the vehicle went supersonic. We've gone through maximum dynamic pressure.
Is chilling in.
That's the greatest aerodynamic stress on the vehicle. We're through that, headed into the upper atmosphere, and headed to the vacuum of space.
And recovery platform has AOS.
AOS is acquisition of signal. That means the drone ship can see the telemetry coming from the Falcon 9. Now currently we're beginning to chill in the second stage engine to get it ready for ignition. Next major event coming up is main engine cutoff and stage separation.
We have MECO 1.
Ignition on the second stage. Yeah, turn it over.
All right, that's a successful second stage burn. You can hear the shears
starting up that second stage burn. The fairing separation is coming up shortly. The fairing, again, is that carbon fiber composite surrounding an aluminum honeycomb that itself surrounds the satellite. It protects the satellite. That's coming up in about 10 seconds.
We're just waiting for it right here. We should have a good video of the fairing separation, and there it goes. That's fantastic news. You can hear cheers here.
Yeah, it's another major milestone. The reason we get rid of the fairing, of course, is it's a lot of excess mass on the vehicle. So when you get rid of it, you can accelerate the rest of the second stage faster and get the satellite that's on top of the second stage all the way to that geostationary transfer orbit without using quite as much fuel.
So now, while the second stage is accelerating, let's talk a little bit about where it's going right now. So we're going to a geostationary orbit. Now, as you guys probably know, going to orbit is not so much about going straight up, as it is about going really, really fast sideways. And so right now we're going to a geosynchronous orbit. This is a lot higher than a low Earth orbit where the International Space Station is, so it takes a lot more fuel to get there. And in fact, the second stage has to make 3 separate orbital maneuvers, or burn maneuvers, in order to get up there. The first is this first burn you're seeing right now on your screen. Then there'll be about a 17-minute coast period, and then a second burn, which lasts about 45 seconds. So.
The main difference between low Earth orbit and geostationary, of course, is that distance. The reason the geostationary in particular is where this satellite is going is because it's going to be staying in the same spot in the sky. That just makes communications with the satellites a little bit easier. In low Earth orbit, you end up making a rotation around the Earth in 90 minutes. The satellite, the International Space Station sees about 16 sunrises and sunsets because it's in that same orbital zone. Geostationary orbit is much further out and it's moving a little bit slower, but angularly it's moving at
about the same speed.
About the same speed as the Earth is rotating.
It's actually pretty high up there. It's 36,000 kilometers up in the sky. So you can see this, we have an animation here showing exactly what the second stage is doing. You can see that first stage going back for landing, and then the first burn, which is happening right now. Then a 17-minute coast period, fairing deploys. And then coming up after the coast period, there's a second burn, really short, only 45 seconds or so. Then the payload separation, and then the satellite itself takes a little while using its own thrusters to get to the final 36,000 geostationary orbit, 36,000 kilometers.
And here's an excellent demonstration. You can see that the satellite staying over that exact same point looks like America in that animation. Of course, this is going to end up over Southeast Asia, but will stay over Southeast Asia for the entirety of its life as long as it stays within that geostationary orbit.
So like we were saying, now when you're exactly in the same spot in the sky, from the perspective of someone on the ground, it's fantastic for communications equipment. If you have a satellite dish, you want to point at the satellite in order to use it for communications, you just take your dish, point it directly in the sky, and it appears as a stationary star, and you can bounce all your communications right off of it.
The same thing is happening with the drone video. When it's got its sort of communications up to a satellite, if the drone is sort of moving too much, as it tends to when you've got
the vibration during launch tends to shake around the satellite on the drone ship quite a bit.
And the vibration during the landing activities.
We just heard that the first burn of the second stage, the first burn of the first stage is complete. That means the first stage is back on its way to a hopefully successful landing soon. Fingers crossed. Fingers crossed.
Stage 1 entry burn shut down. Stage 2 FDF is saved.
So like I said, we're just waiting for the, right now the second stage is still doing its first burn maneuver. This is a few minutes long. Coming up soon here, this first stage is going to be coming back down towards that drone ship.
And as we discussed earlier in this webcast, this landing attempt is going to be quite the challenge. We're flying a GTO orbit, and as Tom and Michael just discussed, GTO missions the satellite in a much higher and much further orbit than our last 2 missions, each of which were to low Earth orbit. Now, this different mission profile makes landing and recovering the first stage significantly more difficult for a few reasons. The first is speed. The first stage will be traveling at a much faster speed than the Orbcom mission, which, as you may remember, was our historic landing back in December. For Orbcom, the first stage was flying away from the pad at about 5,000 to 6,000 kilometers per hour before deploying the second stage and payload and making a U-turn back to the launch site. For SES-9, the stage will be flying away even faster at more like 8,000 or 9,000 kilometers per hour before it separates from the second stage. In order to hit that speed, everyone's clapping. We just heard that prop is nominal on stage 2. That's such good news. So in order to hit that really, really fast speed of 8,000 to 9,000 kilometers per hour, we're going to need a lot of vehicle performance, which the Falcon 9 has plenty of, but high performance requires a lot of propellant. And there won't be as much of it left in the tank as in the stage as we had with low Earth orbit missions. So less propellant means we can't burn the engines as much, and that means slowing the vehicle down. Oh, let's take a look at the drone ship here. Is that the... And the video has frozen out. Oh wait, here we go. Oh, we're seeing something, guys. And we're out. Now, this is something that we expect to see happen when we're landing on the drone ship. That's because as the first stage is coming back, it's shaking. Oh, we're hearing, everyone's cheering. Something good's obviously happened here. But as soon as we get that video, we'll show it to you. Again, this is something that we expect to happen on the drone ship because as the stage is coming back down, it's vibrating the heck out of those cameras. And why don't we just go in and check in on orbit with John Innsbrucker.
It's T plus 9 minutes and 14 seconds, and as you can see on the screen, the upper stage engine has shut down. We are in the low Earth orbit, the parking orbit, the first of 2 burns of the second stage engine. Right now we're waiting to hear a little bit on the orbit. The trajectory looked good as we headed to space, but we're going to wait a little bit to see whether or not the guidance, navigation, and control folks are happy with the orbit that we're in. You also saw just about a minute and a half or so ago, we were waiting to see the first stage come down. We lost the dropout of the signal from the drone ship. We're waiting to hear word on what happened. All we saw was the color bars. We're waiting for somebody to come back and let us know what's happened out there. Part of the difficulty is being over 600 kilometers east of Cape Canaveral. We've got to wait for the shortest ship to connect, and then we'll find out and give you an update a little bit later on. Currently, we are in low Earth orbit. Taking a look here right now, it looks like we've got a good orbit. This is the coast phase that we've entered into now. Now, during this phase, settling valves are going to be pulsing periodically. That's going to settle the fuel and liquid oxygen down into the bottom of the second stage. Now we'll coast, as you heard, for about 17 minutes, and we'll be bringing you the relight then of the second stage engine. At the same time, we're also purging the engine out, getting rid of residuals so that we can continue through the coast phase fairly quiet. The vehicle is just stable as we go through this, doing what we call propellant conditioning, keeping eye on the pressures, making sure the propellant's at the bottom of the stage as we get ready to relight the engine to carry us through the second burn, which moves us into geostationary transfer orbit. Now currently we're looking at telemetry. We've passed beyond the Bermuda ground station that SpaceX has. We'll pick up another ground station in Africa at Gabon. We'll hopefully then have telemetry and video coming back from space to the second stage to understand how we're doing on that burn, and then hopefully spacecraft separation shortly after that. And at the same time, while we're waiting to get to the relight, we'll see if we can get some more word on the first stage landing. But right now, successful launch, we're in orbit, and we're into the coast phase.
So as you heard, it sounds like the second stage and the SES satellite have achieved a good low Earth orbit. This is fantastic news. Like we were saying, this is that we just completed the first of 3 maneuvers, the second being the 17-minute coast period that the stage is now about to coast over.
Yeah, we're excited to hear back about the first stage, whether or not it made it to the drone show. We were watching the exact same video that you did, so we saw all the color bars, and that's when you heard everyone get really sad.